Hello, Colonet Africa online students. Welcome to our 7th lesson in this topic of salts. In this lesson, we're going to look at other or further examples of precipitation reactions or other salts that are prepared using precipitation or double decomposition processes. We're also going to look at the effect of exposure of salt to the atmosphere. And finally, we shall look at the uses of salts. Let's look at other examples of precipitation reactions. We have barium nitrate plus zinc sulfate to get barium sulfate plus zinc nitrate. It's a stoichiometric equation. Remember, sulfate of bariums are insoluble. So we have barium ions plus nitrate ions. Remember, it's a soluble salt, so you can split it or you can write it in separate ions. Then the zinc sulfate, the same case. Barium sulfate is an insoluble salt. It is in solid state, so there's a very strong bond between barium and sulfate, so these ions are not mobile, so they are not free. The zinc nitrate is in aqueous form. That means its its ions are mobile. The cation and anions are mobile, so you can write them separately. This is a stoichiometric equation. Then we can cancel out the spectator ions. The nitrates are spectator ions, so we cancel them out. The zinc and the zinc are spectator ions. Those zinc ions are spectator ions, so you cancel them out. So you're going to be left with barium ions plus sulfate ions to give us barium sulfate. This should be 2. It should be 2, negative 2. The sulfate has negative 2 charge. So correct that one. So you get this barium sulfate. So this is a negative 2. I'm reminding you, you need to correct this one. This is a negative 2 charge. Then red nitrate plus potassium iodide to give us red iodide plus potassium nitrate. The red iodide is insoluble, so this is a stoichiometric equation. You can write the ions that are the aqueous solutions in terms of free ions or free mobile ions. So in this case, that's the equation. So these are the spectator ions. On both sides you can see you have potassium ions and the nitrate ions. So you can cancel the spectator ions. You cancel out the spectator ions so that you're left with the ionic equation. And this is our ionic equation. Red ions plus the iodide ions to give us red 2 iodide. And we have the nitrate. So these are the spectator ions. Silver nitrate, the nitrates. Then we have sodium ions and the chloride ions. So you can see we have silver chloride solid. So if you look at this side, we have the nitrate and the sodium ions, and also on the other side we have the sodium ions and the nitrate ions, which are spectator ions, so they are cancelled out. So you made them to get that as our ionic equation. Similarly, copper chloride plus sodium carbonate to give us copper carbonate plus sodium chloride. This is a stoichiometric equation. So we have these are spectator ions, the sodium ions and the chloride ions. These are our spectator ions. You omit them or you cancel them out to get this ionic equation. In a precipitation or double decomposition reaction, 2 reactants must be soluble salts and one of the product must be insoluble. Then let's look at the effect of the exposure of salt to the atmosphere. We're going to look at experiment 4.10. What happens when salts are exposed to the atmosphere? This is a procedure. Place a spatula full of the following salt in separate watch glasses, labeled 1 to 6, and leave the samples uncovered overnight. We have the common salt, that is sodium chloride, anhydrous calcium chloride, potassium nitrate, hydrated sodium carbonate, that's our hydrated sodium carbonate. Then you have anhydrous iron 3 oxide. Then observe and record any change that may be observed or that may occur when you expose them in the atmosphere. Then, when anhydrous calcium chloride is exposed to the atmosphere overnight, it turns or it forms a colorless solution, which means calcium chloride dissolves or absorbs water from the atmosphere. Remember, in the atmosphere you have water vapor, so it absorbs that water vapor, dissolves in it, and forms a solution. The shiny black crystals of iron 3 chloride also forms a yellow solution, which means they absorb water from the atmosphere, they dissolve in that water and form a solution. This is because they absorb so much water from the atmosphere and dissolve in it to form a solution. Such salts are said to be deliquescent. So deliquescent salts will absorb water from the atmosphere, dissolve in it, and form a solution. And the process is called deliquescence. Other deliquescent substances include sodium hydroxide, pellets, calcium chloride, iron 2 chloride, potassium hydroxide pellets, and zinc chloride. They all absorb water from the atmosphere, dissolve in that water, and form a solution. When anhydrous copper 2 sulfate is exposed to the atmosphere, the white solid turns blue and becomes damp. In other words, it doesn't dissolve in that water to form a solution. And we normally use anhydrous copper 2 sulfate in the test for the presence of water, because you're going to find that in anhydrous form it is white, but when it absorbs water it is blue in color. This is because it absorbs water of the atmosphere and do not dissolve in it, and that's why it is damp. These salts that absorb water from the atmosphere and do not dissolve in it are said to be hygroscopic, and the process is said to be hygroscopy. When crystals of hydrated sodium carbonate, that is sodium carbonate decahydrate, are exposed to the atmosphere, a white powder is formed, which means they lose the water of crystallization. This is because the crystals lose some water of crystallization to form a white powder and are said to be efflorescence. So you're going to find that those compounds that are salts that lose their water of crystallization to the atmosphere, once they are exposed to the atmosphere, they are referred to as efflorescent compound, and the process is referred to as efflorescence. Efflorescence. So correct this one. This one should be efflorescence. Efflorescence. Sodium carbonate monohydrate also loses water of crystallization to the atmosphere and are said to be efflorescent compounds. The process through which compounds or salts lose water of crystallization to the atmosphere is referred to as efflorescence, and that's why it's said you collect this one to be efflorescence. Other examples of efflorescent salts include iron 2 sulfate, heptahydrate. It will lose the water of crystallization to the atmosphere once it is exposed to the air, and sodium sulfate decahydrate. They all lose their water of crystallization to the air. Then let's look at the uses of salts. Salts are widely used in the manufacture of fertilizers. Salts such as sodium nitrate, potassium sulfate, ammonium nitrate, ammonium sulfate, and ammonium phosphate are normally used in the manufacture of fertilizers. They are also used for food additive such as sodium chloride that we normally use, the common salt that is used in households as food additive to add flavors in food, and also hydrogen carbonate used in baking powder. Sodium sulfate, also known as plaster of Paris, is normally used in the hospital on the people with fractures or dislocation. Many salts are used for defrosting snow in cold countries, that is in western countries, during winter by lowering its freezing point. For instance, calcium chloride is applied on the load to melt snow in those areas that are in the North Pole and the South Pole, where we have the snow falling. Calcium chloride is used in the road surfacing to keep the road moist due to the liquescence nature of the calcium chloride. It absorbs water, dissolves in it, and forms a solution. Calcium is used in the extraction of sodium metal by electrolysis. Potassium nitrate is used to make fireworks and gunpowder. And that brings us to the end of our 7th lesson. So you have the assignment 7. You need to look at all those questions, answer all the questions, and we meet in our next lesson, that is lesson 8, next time, and have a good one. Bye.